this session, we'll discuss how the coordinate maps are used to minimize Boolean functions. The coordinate maps can be drawn for the 2 variables, 3 variables, and 4 variables, and 5 variables also. But here we are limited the discussion to 2 variables, 3 variables, and 4 variables. First, we'll see that how to draw the coordinate map for the 2 variables. Within the 2 variables, one variable can be considered as the row variable and another variable can be considered as the column variable. The row variable value contains the values as 0 and 1. So the first 0 represents the value of A is equals to 0. And the next row represents the value of A is equals to 1. Similarly, for the column variable, the B value is either it can be 0 or 1. So the first column represents the B value as 0 and the next column represents the B value as 1. And whatever the numbers we had written in these boxes, these numbers represents the minterms. Minterms represent the combination of row variable and the column variable. So it is decimal equivalent values for the combinations of row and column variables. So 0, 0 can be represented as 0, 0, 1 can be represented as 1, 1, 0 can be represented as 2, and 1, 1 can be represented as 3. Similarly, we can draw the 3 variable K-map. 3 variable K-map can be written in 2 ways. One way is by considering the 1 variable as the row variable and 2 variables as the column variables. And even we can draw this K-map whereas considering 2 variables for the row and 1 variable for the column. So here we are taking one representation where one variable can be represented as row variable and the remaining 2 variables can be used as column variables. So for the row variable, its combinations are 0, 1, and for the column variables, its combinations are 0, 0, 0, 1, 1, 1, and 1, 0. And remember that here, whenever we are using the two variable combinations, always these are written in the form of gray code forms. So because of that reason, after the 0, 1, you should not keep the combination as 1, 0. You should keep the combination as 1, 1. After that only, you should write down 1, 0. So whereas all the minterms can be written in terms of gray order. So the minterms within these squares represented as 0, 1, 3, 2, 4, 5, 7, 6. Similarly, we can draw the 4 variable K-map. Within the 4 variable K-map, we can consider 2 variables as the row variables and 2 variables as column variables. So for the row variables, the combinations are 0, 0, 0, 1, 1, 1, 1, 0. And for the column variables, the combinations are 0, 0, 0, 1, 1, 1, 1, 0. So the combinations for these squares represents 0, 1, 3, 2, 4, 5, 7, 6. And here the order is 8, 9, 11, 10. So then we should go for 12, 13, 15, 14. So to solve the Boolean functions, compulsory we should remember this order of the minterms. So this order plays very, very important role. So now we'll see that minimization of K-maps. While minimizing the Boolean functions by using K-maps, we should follow some rules. The first one is groups may not include any cells containing a 0. So while minimizing the expressions, we should group the zeros and ones. So here we are going for the discussion of minimizing the expressions in terms of sum of product terms, that is by using minterms. So we are concentrating on grouping of ones. While grouping of ones, we should not include zeros. So the group may not include any cell containing 0. So this way of making grouping is wrong. This is the correct option. And the groups may be only horizontal or vertical, but it cannot be diagonal. The group must contain 1, 2, 4, 8 or any value which can be written in terms of 2 powers. That is, if n is equals to 1, group will contain 2 ones. If n is equals to 2, the group it may contains 2 power 2, that is. And while grouping the things, suppose if it is a 3 variable K map, first we have to check that whether the group contains all 8 ones. So if it does not contain 8 ones, then we have to group the 4 ones. Then we have to go for the grouping of 2 ones. Then we should consider a single one. So while minimizing the K map or while grouping the ones in the K maps, always we should start with the higher numbers. So this example represents group of 2. So we should not make the group of 3 because the 3 cannot be written in terms of 2 powers. And we can make the group of 4. So again, group of 5 or the group containing zeros is the wrong option. Each group should be as large as possible. So here, if we consider the same example, we should not group 2 ones together. So first, already I told that first we have to check for the 8 ones, next 4 ones, next 2 ones, next single ones. So first we should check that whether group of 4 ones are possible or not. After that only we should go for the pair of ones. So this is the right option and this is the wrong option. Each cell containing 1 must be in at least 1. We should form the group such that whether we have to check that this one can be covered by any other group. So mainly while minimizing this expression, if you are considering any variable or any minterm, that minterm must be covered by any one of the group. Right. So here instead of considering a single one, you can make it as one pair. Sorry. And while grouping the groups, it may overlap. So here, if you observe the example, these ones and these ones, the group of 4 ones can be overlapped with this particular group of ones. So the groups overlapping can also be done while minimizing the Boolean functions. Groups not overlapping concept is wrong because here we can make these 4 ones as one group and these 4 ones as one. Groups may wrap around the table. The leftmost cell in a row may be grouped with the rightmost cell and the top cell in a column may be grouped with the bottom cell. So that means we can map we can group these 4 ones and these ones. We can map like this or we can group like this or like this. So here whatever may be the grouping or whatever it may be, so always we are trying to group the adjacent ones. The adjacent ones. Right. So if we consider 0, 1, 1, 1, so it may contains only 1 bit difference. So if we in the combinations, if it contains 1 bit difference, we can make or we can group those two ones. So now we'll see one example how to write down the minimized expression by using this 3 variable k-maps. Suppose if there is a function such as z is equals to sigma abc of 1, 3, 6, 7. So here it is very clear that within these minterms or these minterm values will be equals to 1 and the remaining minterm values will be equals to 0. So first we have to draw the 3 variable k-maps and we have to keep ones at the positions where these midterms are there. So here at the 1, 3, 6, 7, we should keep the values as 1. Next, we'll see that how to write down the expression. So to write down the expressions, first we should make it as groups. So these two ones will make it as one group and these two ones will make it as another group. So even though there is a chance of grouping this particular pair, but already this one is covered with this group and this one is covered with this group. So no need to take this particular pair. So only you have to write down the expressions for the two groups. While writing the expression for these groups, you have to consider the values of A, B, C. And while writing the expression, you should take only the common variables. So for this 1, 1 pair, the A value is common and its value is 0. So whenever the A value is 0 for this particular pair, you should write down A bar. If the A value is 1 for this pair, you should write down the A value as 1. So for this combination, the A value is 0. So you should write down the expression such that A dash. Next, within the B and C combination, you have to check what is the common variable. So here the B value is 0 for this one and B value is 1 for this one. So you should not take you should not consider the B as a common variable. So then check for the C value. C is equals to 1 for this one as well as C is equals to 1 for this one. So C can be considered as a common variable and since C is equals to 1, directly you can write down C in the expression. So for this particular pair, the expression is A dash C. Next, for this particular pair, the common value of A is equals to 1. So you should write down or you should take the direct variable, that is. Next, we should check the combinations of B and C. So here B value is equals to 1 for both the combinations and C value is different, that is here C equals to 1 and here C is equals to 0. So you should not consider the C. So we should take only B value. So for this one, the term value is equals to A, B. So overall, this particular function can be written as A dash C plus A, B. Similarly, we can discuss the 4 variable k-map simplification. So these are the midterms on which for this midterm the values will be equals to 1s. So first you should write down the 1s here. So after that you should go for the grouping. So these 4 ones will make it as one group and the corner ones will make it as another group. So for this group of ones, so just check for the common value. So here the Q value is common and the P value is different. So for this expression, we should consider the Q value. Next, similarly, you should consider the RS values. So here R value is different and S value is same. So you should write down the expression for this particular group as QS. Similarly, for these corners, so observe the Q value is same and the P value is different. And since the Q value is equals to 0, you should write down the term as Q bar. Similarly, for these two, the S value is 0 and the R value is different. So you should consider the S and since the S value is 0, you should consider the value as this bar. So the expression for this particular two groups or for this particular function can be written as QS plus Q bar S bar. So in this way, by using coordinate maths, we can simplify any Boolean expression. Thanks for listening to class.